Imagine a 90,000-ton steel fortress, a city at sea, charging through waves taller than a 9-story building. Water crashes over the flight deck with enough force to rip aircraft elevators clean off, and the entire ship pitches violently while 5,000 sailors fight to keep operations running. This isn't a disaster movie. This is the stark reality for aircraft carrier crews battling the world's roughest seas. What most people don't realize is the untold story of how these floating cities survive conditions that would sink almost any other vessel, yet they continue launching jets, feeding thousands, and maintaining combat readiness. The engineering behind their survival is incredible, but it's the men and women aboard who truly make the impossible routine. When people think about aircraft carriers, they often picture sunny skies and calm seas, but the reality involves brutal conditions most civilians never see. Modern supercarriers measure over 305 meters long and stand 73 meters tall from keel to mast. These engineering marvels carry between 5,500 and 6,200 crew members who live and work in conditions that relentlessly test human endurance and military discipline. The ocean doesn't care how advanced your technology is. Mother Nature has sunk more naval vessels throughout history than enemy action ever has. Massive storms have destroyed warships and killed hundreds of sailors in single events. Even the mighty aircraft carriers face waves that crash across flight decks, designed to handle fighter jets traveling at 240 kilometers per hour. The critical difference between those who make it through and those who don't comes down to preparation, engineering, and the exceptional skill of naval personnel. If you've ever wondered how these crews manage such extreme conditions, drop a comment below and let us know what amazes you most about carrier operations. Understanding how carriers survive starts with basic physics that most people never consider. These ships aren't just big, they're specifically designed to resist one of nature's most destructive forces. Carriers have been documented plowing through seas with waves so massive they swept completely over the bow and hit the bridge windows. Video footage from various deployments shows helicopters and fighter jets chained to the deck while water cascades over them like a waterfall. Yet the carriers kept moving, and the crews kept working. That's not luck. That's intentional design meeting trained excellence. Aircraft carriers achieve stability through a principle called the center of buoyancy versus the center of gravity. Think of it this way. The ship's weight concentration sits lower than the point where buoyancy forces push upward. When a wave tips the carrier, physics actually works in its favor. The farther it tips, the harder the buoyant force pushes to right the ship. It's like a self-correcting mechanism built into the entire design. The hull underneath the waterline spreads wide and flat, creating a stable platform that resists capsizing. Modern carriers also use a V-shaped bow to slice through waves rather than ride over them, which significantly reduces the pounding force on the entire structure. Above the waterline, there's a pronounced flare that deflects water away from the deck and further enhances stability. Engineers spent decades perfecting these features after learning hard lessons from earlier carrier designs. Earlier carrier classes provide stark examples of what happens when design falls short. Some older vessels sat too low in the water with insufficient freeboard, which is the distance between the waterline and the deck. In heavy seas, they became dangerously wet. Waves constantly washed over the deck, hindering flight operations and creating unstable conditions. During particularly bad storms, some carriers even had aircraft elevators torn completely off by wave action. Crews describe these ships as plowing through waves rather than riding over them, making every storm a battle for survival. Modern carriers have learned from those mistakes. Today's advanced ships incorporate ballast systems that actively adjust the vessel's trim and stability. These systems pump water between different tanks to maintain level flight decks even in rough seas. Gyroscopic stabilizers also counteract rolling motions, though they do have limits. No technology can completely defeat a hurricane when nature unleashes its full fury. The ocean has its moods, and sailors learn to read them. But sometimes nature strikes without warning, and that's when training separates professionals from amateurs. Rogue waves present one of the most terrifying phenomena at sea. These aren't your typical storm waves. Rogue waves are unpredictable walls of water exceeding 24 meters that appear suddenly, often in otherwise moderate seas. They form when multiple wave patterns converge, creating a temporary mountain of water with devastating power. A rogue wave can hit a carrier's bow with millions of kilograms of force, concentrated in mere seconds. Carriers have encountered exactly this situation multiple times throughout naval history. Waves estimated at 27 meters tall have battered these massive vessels for hours. The flight deck, normally 18 meters above the waterline, can disappear under cascading seawater. Aircraft must be secured with multiple chains because standard tie-downs won't hold against the violent pitching. Crew members below deck report feeling the entire ship shudder with each wave impact. Yet, operations continue. The galley keeps serving meals. Engineering maintains propulsion. The crew adapts, because that's what sailors do. Recent operations around the world have demonstrated ongoing challenges with extended deployments in harsh conditions. Carriers spend months deployed, constantly facing rough weather, while under intense operational pressure. Crews deal with a high operational tempo, meaning constant flight operations, maintenance, and combat readiness drills, all while the ship pitches and rolls through challenging seas. These are not pleasure cruises. Sailors work 12 to 16-hour shifts in conditions that would send most people running for shore. The physical toll on crews in these situations cannot be overstated. Imagine trying to perform precision maintenance on a fighter jet while the deck beneath you shifts unexpectedly. Picture conducting surgery in the medical bay when violent rolling makes standing upright nearly impossible. Think about the cook trying to prepare thousands of meals when pots slide off stoves and gravity stops working in predictable ways. Before we continue, take a quick moment to hit that like button and subscribe to this channel. Over 98% of you watch without subscribing, and it costs you nothing but makes a massive difference to us. We truly appreciate your support. Technology and engineering matter, but people make the real difference. Every sailor aboard a carrier trains extensively for heavy weather operations, and that training starts long before they ever step onto a ship. Basic training introduces sailors to damage control fundamentals. They learn about watertight integrity, the system of doors, hatches, and seals that compartmentalize the ship. The Navy uses a condition system called X-ray, yoke, and zebra. Think of these as security levels for the ship's internal structure. Condition X-ray is set during normal operations in port, with most access points remaining open for easy movement. Condition yoke provides intermediate protection and typically gets set when the ship operates at sea during peacetime. Fittings marked with a Y stay closed to provide reasonable protection while still allowing operational access. Condition zebra represents maximum watertight integrity. When zebra is set, every possible opening seals shut to create the greatest subdivision and survivability. Heavy weather automatically triggers zebra conditions because one breach in the hull could flood multiple compartments if doors remain open. Flight deck crews face unique challenges during rough weather. These sailors work in one of the most dangerous environments in the military, even in calm seas. Now add 80 kilometers per hour winds, driving rain, and a deck pitching 15 degrees in multiple directions. They still have to safely launch and recover aircraft worth $60 million each, while wearing heavy protective gear and communicating through precise hand signals. The precision required is extraordinary. One wrong step, one moment of inattention, and someone could die, or a jet could plunge into the ocean. Yet, these crews maintain nearly perfect safety records because their training emphasizes teamwork, communication, and constant awareness. Each person on the flight deck knows exactly what everyone else should be doing at any given moment. They watch each other's backs because survival depends on it. Engineering crews deep within the ship face different but equally demanding conditions. They maintain the nuclear reactors that power the carrier, plus the steam turbines, electrical systems, and countless other mechanical components. When heavy seas cause violent rolling, maintaining balance becomes a constant struggle. Equipment can come loose, pipes can rupture, and systems that worked perfectly yesterday might fail today, because extreme motion stresses every connection and joint. Experience has shown that a high operational tempo and extended time at sea can contribute to mishaps. Fatigue becomes a real concern when crews work excessive hours under stressful conditions. The Navy has learned valuable lessons about crew rest requirements and operational limits. Even the best trained sailors have breaking points, and responsible commanders must recognize when pushing harder creates more risk than reward. When weather forecasts predict severe conditions, carriers don't just button up and hope for the best. They execute detailed preparation checklists developed over decades of experience. The first priority involves securing everything that can move. On the flight deck, aircraft are chained down with multiple tie-downs rated for extreme loads. Loose equipment is stowed or lashed to the deck. Anything that could become a projectile in 110 kilometers per hour winds must be secured or removed entirely. One loose tool cart sliding across the deck could kill someone or damage an aircraft. Below deck, the crew methodically secures compartments. Heavy items receive additional lashing. Doors and hatches undergo extra inspection to verify proper sealing. The galley secures pots, pans, and kitchen equipment. Medical facilities prepare for potential injuries by staging emergency supplies and briefing personnel on heavy weather treatment protocols. The bridge team updates weather information constantly. Modern carriers receive satellite data, numerical weather models, and reports from weather routing services. Commanders make critical decisions about course and speed based on this information. Sometimes the best option involves altering course to avoid the worst conditions entirely. Other times, operational requirements mean pushing through regardless of the weather. The ship's speed and heading relative to waves makes an enormous difference in how rough the ride becomes. Taking waves directly on the bow, called heading into the seas, generally provides the smoothest ride and least stress on the entire structure. The V-shaped bow cuts through waves rather than riding over them. However, this might require deviating from the desired course, which could delay arrival or affect operational timelines. Taking waves on the quarter, the rear corner of the ship, allows maintaining course while providing reasonable stability. The carrier's size and momentum carry it through waves without excessive rolling. The danger comes if waves hit directly from the side, called beam seas. Beam seas create maximum rolling motion and stress the entire structure significantly. Skilled commanders avoid beam seas whenever possible. Communication becomes vital during heavy weather preparation. Leadership briefs all department heads on expected conditions and timelines. Department heads then brief their divisions. Information flows through the chain of command until every sailor understands what's coming and what their role involves. Engineering receives advance notice to prepare propulsion systems for demanding conditions. The galley adjusts meal schedules and menu options. Medical personnel prepare for potential casualties. This systematic preparation explains why modern carriers rarely suffer catastrophic weather damage, despite facing conditions that would destroy lesser vessels. The combination of robust engineering, detailed procedures, and well-trained crews creates multiple layers of protection. When the storm hits, theory meets reality. No amount of preparation fully captures the experience of riding out truly severe weather aboard a carrier. The ship takes on a different personality in heavy seas. The steady hum of normal operations is replaced by groaning metal, rushing water, and wind howling past the island's superstructure. The deck pitches and rolls in ways that make walking straight impossible. Sailors learn to time their movements with the ship's motion, moving during stable moments and holding tight during rolls. Below deck, most crew members never see outside during their entire shift. They might work for 12 hours straight in compartments deep within the hull, feeling the motion but not seeing the waves causing it. Some find this worse than being on deck, where you can at least see what's happening. Others prefer not knowing. Either way, the job continues. Sailors don't get time off because the ocean got rough. Flight operations typically cease when conditions exceed safe limits. The Navy has specific criteria for wind speed, deck motion, and visibility that determine when to suspend launches and recoveries. A pitching deck makes landing nearly impossible. The carrier's stern might drop 6 meters just as a pilot tries to catch the arresting wire. One miscalculation, and the jet crashes into the stern or overshoots into the water. No mission is worth that risk. But even when flight operations stop, the carrier maintains readiness. Aircraft are inspected and maintained. Crews rest and prepare for when the weather improves. The ship continues its mission of projecting power, just in a reduced capacity temporarily. The galley faces unique challenges feeding thousands during heavy weather. Hot cooking surfaces become dangerous when the ship rolls unexpectedly. Some menu items become impossible to prepare safely. The galley switches to simpler meals that can be served safely in rough conditions. Nobody complains because everyone understands the situation. Sailors appreciate having hot food at all when conditions get severe. Medical teams stay alert for injuries. Sailors can lose footing and fall despite grab rails and non-slip surfaces everywhere. Something as simple as going down a ladder becomes hazardous when the ship pitches unexpectedly. Broken bones, sprains, and concussions happen despite everyone's best efforts. The medical staff handles these situations professionally, treating injuries and getting sailors back to duty when possible. Engineering crews maintain constant vigilance over propulsion and electrical systems. The nuclear reactors keep running, providing power for everything from radar to galley refrigeration. Steam turbines spin at thousands of RPM despite the violent motion. Thousands of components must work flawlessly because losing propulsion in heavy seas could prove catastrophic. Engineers take immense pride in keeping everything running no matter what conditions they face. Damage control teams stand ready to respond instantly to any emergency. A breach in the hull, a fire, flooding, or structural damage could happen at any moment in severe weather. These teams train constantly for scenarios most people hope never happen. They know their equipment intimately and can respond in darkness, in smoke, or while wearing full protective gear. Their readiness provides insurance that keeps everyone else alive. When the weather finally breaks and conditions improve, the work isn't over. The crew conducts systematic inspections to identify any damage from the storm. Topside teams check the flight deck for damage. They inspect aircraft tie-downs, look for loose equipment, and verify that no structural damage occurred. Even minor cracks or dents are documented because they could indicate stress points that need attention. Aircraft receive thorough inspections before flight operations resume. Salt spray and wind-driven rain can affect sensors, engines, and avionics systems. Below deck, engineering teams inspect critical systems. They check for leaks, verify proper operation of pumps and valves, and look for any indication of stress damage. Every compartment is inspected systematically. Damage control teams verify watertight integrity throughout the ship. One small leak left undetected could cause major problems later. Leadership reviews reports from all departments and compiles lessons learned. What worked well? What could improve? Did any procedures fail or need modification? This continuous improvement process means each heavy weather experience makes the ship and crew better prepared for next time. Recent operations provide valuable examples. Extended deployments have resulted in mishaps that investigators traced partly to operational fatigue. The Navy acknowledged that even with excellent training and equipment, pushing crews too hard for too long creates risk. This honest assessment led to policy reviews about deployment lengths and crew rest requirements. The willingness to examine failures and adapt demonstrates the professionalism that makes the Navy a world leader. Historical incidents provide equally important lessons. Carriers have survived devastating typhoons, but suffered severe damage when violent rolling caused fires, washed aircraft overboard, and led to loss of steering. Crew damage control efforts saved these ships, but the incidents taught valuable lessons about heavy weather preparation and response that influenced carrier design for generations. Earlier carrier struggles with low freeboard and poor seakeeping led to fundamental changes in carrier design philosophy. Modern carriers sit higher in the water and incorporate features specifically intended to handle rough seas better. Every design decision in current carrier classes reflects lessons learned from earlier vessels that faced nature's fury. Technology continues advancing, but the fundamental challenge remains: humans and steel versus the most powerful force on the planet. Modern carriers incorporate advanced weather monitoring systems that provide unprecedented situational awareness. Satellite data, sophisticated forecasting models, and real-time sensor information give commanders tools earlier generations couldn't imagine. This information allows better routing decisions and more accurate preparation timing. Automated systems help manage stability and trim. Computer-controlled ballast systems respond faster than manual pumping ever could. Advanced radar provides early warning of approaching severe weather. Communication systems keep ships connected with weather routing services and shore-based forecasting centers. Yet technology cannot eliminate the ocean's power. The Navy recognizes that human judgment, training, and resilience remain the ultimate deciding factors. Investment in personnel training continues growing because the best sensor systems and automated controls still need skilled people making decisions. The newest carrier classes incorporate lessons from decades of heavy weather operations. They feature improved damage control systems, better crew spaces, and enhanced stability characteristics. But they still face the same ocean that has challenged sailors since humans first ventured offshore. The difference lies in preparation, training, and the exceptional quality of naval personnel. Climate change may bring new challenges as weather patterns shift and extreme storms potentially become more frequent. The Navy studies these trends and incorporates findings into ship design, operational procedures, and training programs. Adaptation has always been a naval strength, and that will continue. Aircraft carriers facing giant waves represent one of the ultimate tests of engineering meeting human courage. These floating cities endure conditions that would terrify most people, while maintaining readiness to project power anywhere on the globe. The crews aboard these vessels train constantly, prepare systematically, and perform extraordinarily when nature tests them. Their success comes from the combination of brilliant engineering, detailed procedures developed over decades, and most importantly, the exceptional men and women who serve. These sailors embody the Navy's core values of honor, courage, and commitment every single day at sea. Understanding what they face and how they overcome it should instill pride in our naval forces. These are the people keeping us safe while facing challenges most of us will never experience. If you found this informative, please hit that like button and subscribe for more content about the incredible capabilities of our armed forces.